One of the major importance of CFD is that it is very inexpensive. It is cheaper than conducting wind tunnel experiments, which require making actual models of what is being tested. Making a model prototype can be expensive than a computer-generated model, and you can get faster and better results from your simulation. Most of the time, wind tunnel testing is conducted to validate the results obtained with computer simulations. Not only is it useful for aerodynamics, but CFD can be applied to almost any type of experiment with moving fluid. CFD is a very important engineering tool and is applicable to a wide range of experiments.
In fluid dynamics, drag, sometimes called air resistance, is a type of friction that is a force acting opposite to the relative motion of any object moving with respect to a surrounding fluid, whether that fluid be air or water. The frictional effect on the surfaces due to drag, it creates a lot of undesirable effects. So a reduction in drag will actually reduce the fuel consumption in any sort of vehicle, and it also increases the safety and durability of different geometries that are subjected through high velocity fluids. It can also reduce noise and vibration, just creating an overall better system. The main way engineers can actually reduce drag is by redesigning or overhauling the geometry of whatever object they're dealing with in order to allow fluids to flow over the object more easily.
To start, we're going to open Ansys Workbench, select Fluid Flow Fluent, and then right-click on Geometry, select Properties, and change it from a 3D to a 2D model. Once that's done, we're going to right-click on Geometry again, select New Design Modeler, go to Sketching, select Settings, and check Show in 2D and Grid. Then we're going to change the major grid spacing to 1 meter and minor steps major to 10. Click Draw, then select the Z-axis in the bottom right corner so that we can zoom in to draw our figure. As you can see, we're using the line command and the arc commands, whether it be arc by center or arc by 3 points. Select Modify and Trim to get rid of all the excess lines that we no longer need. A big box around the vehicle to act as a wind tunnel or a fluid flow area, and make it a fluid model by selecting on the surface body. Then we'll select Concept, choose Surface from Sketches, and choose Sketch 1, and then Apply and Generate. And once that's done, we're going to go back to Workbench, select Meshing, and begin by naming the inlet and outlet. We're going to select Meshing, go to Mesh Control, select the body, and make it an all triangles method. Then we'll go back to Mesh Control, select Sizing, and then select all the lines and components that make up the figure inside the wind tunnel. And we'll change the element size to a suitable size. Change the behavior to hard. Once done, we're going to change the relevant center to fine and the max face size to a more appropriate 0.05. Then we're going to click Generate. Then we're going to click Generate, and we have our mesh. Nice and small to give us the best reading possible. Select Setup, then check Double Precision and Parallel and change the processes to 6. Once we get that page brought up, we're going to change time to transient instead of steady. That way we can see how it reacts over time. We're going to change the model for viscous laminar to K epsilon. And then we're going to leave everything else the same for that page. We're going to change the boundary conditions for the inlet. That way we have a velocity going into the inlet. Check the outlet. It's all good. And then change our residual monitors to give us a more accurate answer. Then we're going to initialize it, and we're going to choose to hybrid initialize it. And then we're going to make animations, or get set up to make animations. We're going to use pressure and velocity, contours, and we need to change iteration to time step so that we can make those videos. And we're going to choose to have it filled, choose pressure, and then select pressure so that we can save it, and then we have our animation, and then repeat the process for velocity. Now with that done, we're going to choose an appropriate amount of time steps, in this case 0.05. Number of time steps, we'll make them 100, and then we'll make the max iterations 30, and then we'll calculate. And once it starts calculating, all that's left is wait for the results.
Alright, so first you have to open up Fluent and get a active thing ready, and then you're going to go over to the properties and change it to 2D properties. In this case, I have a geometry already pre-made, so I'm going to go ahead and import it into this new thing. And I'm going to restart, kind of break down exactly what I'm going to plan on doing. So first we kind of have to just wait for it to start up, let it do its thing. So off to the left, you can kind of see that there's a ton of stuff already there, and I'm going to explain what each of these things do as I kind of backtrack and remake everything. So instead of remaking my sketches, I'm just going to kind of show you. Here they are. I have one sketch, which is the car, and I have a second sketch, which is my wind tunnel, or just a rectangle that the car's in. So I'm going to make a surface from these sketches. I'm going to make a surface with my car, and I'll click generate, and there it is. And then I'm going to make a surface out of the wind tunnel, which I'm going to go ahead, instead of add material, I'm going to add frozen, which is going to help differentiate between the two. So now they're overlapping. What I need to do is I need to specify where the car is. So what I'm going to do is I'm going to create a Boolean. And what this will do is it's going to subtract the car geometry out of the rectangular geometry. Now, you don't have to use a car. You can use whatever you want. The car is what I wanted to do, but the process should work the same no matter what you use, whether it's a car or a boat or whatever. It should work fine. And now keep in mind, this is a two-dimensional thing. So there's no tires because the tires are only on a select section. I went ahead and changed it from fluid or from solid to fluid because this is supposed to be air. So from here, we can go ahead and close out and go to our mesh. So once the mesh actually loads up and everything, you're going to see our geometry in the mesh file. So what we need to do here is we're going to go ahead and tell the program the method of the mesh that we want to use. So what this is doing is we're going to tell it what shapes we want the mesh to mainly be. So we're going to change it from quadrilateral to triangle so we can have a tighter overall, smoother look for our mesh. So if I update now, it's just going to automatically do this thing. It's going to make a mesh, and they're very big triangles, and we need to kind of close them down. So I'm going to do a sizing tool around the car's border itself. And what this will do is it's going to tell the mesh that I really want a whole lot of detail right next to the border of the car because that's where I'm trying to focus. Now I'm going to go ahead and lower the element size just so I can kind of get a tighter mesh around the overall car. As you can see, it looks good. And then of course behavior of this is going to be hard instead of soft because it's a car. So now you can see how much tighter the mesh is around the car, which is telling us that it's going to be a lot more detailed there. So now we're going to kind of clean up everything. We're going to refine the overall mesh. Now you can refine it to a refinement of 1, 2, 3, whatever. Typically you can start at 3, and if it doesn't work, you can bump your way down to 2. I'm just going to go ahead and do 2. I don't need a whole lot more than that. So I look at the mesh. You can see now that all those huge triangles have shrunk down. It's cleaned up the mesh and it's focused a lot more around the car as well. But still not very pleased with it. So I'm going to go ahead and change the relevant center to fine. I'm going to go ahead and change the max face size. It's at 0.23. So I'm just going to kind of lower it down a little bit to 0.2. And then I'm going to go down to the quality tab and I'm going to go ahead and change it from medium smoothing to fine or high smoothing, just so overall it tightens my mesh and creates a good overall look for a better calculation. So as you can see, it's very tight, very small. It's going to give me a very accurate simulation for this case. So make sure you always label your parts. That way when you're running your simulation, you know which parts are doing what. So I have my inlet, my outlet, and then I'm going to go ahead and name the top and bottom the walls because that's just what I want to do. I made a typo there for outlet. I'm going to fix that. So I'm going to all right, just wall, and then here's my outlet. I'm going to fix that. Instead of outlet, it's going to be outlet. And then I'm going to go ahead and name the car as well. So make sure whenever you're doing this, you have the edge selector tool selected, just so we're picking out specific parts. So I'm going to let this do its thing. All right, so now we have all our parts labeled. That's good. Make sure you save and update your program every single time you do it, just so we make sure that everything works fine. And then from here, what we're going to do is we're actually going to close out of our mesh, and then we're going to start setting up our solution. So when I do the setup, I'm going to double click it. I always just do double precision. I don't know why, that's what I've been taught. So the processes is the number of cores that your program or that your computer itself actually has. In my case, I have an i5 6600K, so it has 4 processes, it has 4 cores. So I can select 4. And then GPU, that just depends on your system as well. This is where the simulation itself runs. And you can see that our mesh is in there. And I'm going to select transient because it's an unsteady state. I'm trying to make this as realistic as I can, so I'm going to choose an unsteady state. Then for our models, we don't need to deal with anything other than viscous model. The real world isn't laminar. So what we're going to have to do, we're going to choose a turbulent model. So in this case, I'm choosing K epsilon. I'm not going to mess with any of the different settings. I'm just going to click K epsilon, let it do its thing. And then we're going to make sure that we have air in our fluid toolbox, and you can go ahead and check. If you aren't doing air, you can select the Fluent database, or you can do your own database and change all the different properties yourself. And from here, what we can do is we'll go down to our boundary conditions. So we're going to check out our inlet, and our inlet's going to be velocity inlet, which it should show. And if it doesn't show that it's a velocity inlet, then something happened with your thing and you need to go back to your geometry. I'm going to set it to 30 meters per second because that's roughly 65 miles an hour, give or take. That's speed on the highway. I'm going to change the turbulence to intensity and length scale, and then I'm going to go to outlet. I'm not going to mess with anything other than changing the turbulence to intensity and length scale. And I'll go ahead and click OK. And so now we're going to have to go and change a couple other things. We're going to need to select our method, which is how the program is actually solving this specific scenario. And so what I'm doing is I'm changing pressure to standard, and then turbulent, I want it to be very specific. So I'm going to bump it up to second order upwind instead of first order. And then the transient formulation, you don't need to mess with that. That's just specifically dealing with your unsteady state. We don't need to worry a whole lot about that. So now what we're going to do is we'll go to initialization. Don't deal with the standard, just go ahead and do hybrid. We don't have to worry a whole lot about what's going on with that. So once we initialize, it'll give us an extra option in our calculation activities that is actually going to let us run a solution animation. So once we go ahead and click the solution animation, it'll pop up with this little window. Make sure you have time step selected. It's just easier to deal with, in my opinion. Make sure you have HSF file as your storage type, and then you can name the animation whatever you want. I'm choosing contours. You can do vectors, you can do anything. And these are just my general settings. The more color map size, or the bigger your color map size, the more colors are in your thing, which is going to give you a smoother overall look. And then on top of that, if you select filled and smooth, it's going to just give us a better look. As you can see over here, this is what our car is going to look like, just the starting point. And so I'm going to go ahead and close out of this. I'm going to make sure I select contour for my velocity, and then I'm going to click OK. So now you can see my velocities with my solution animation. I'm going to do the same thing again. I'm going to do it with pressure though. This is just going to help me visualize what's going on with the car itself. And we can do filled, smooth, 99 color map size, then change it to pressure. And it should save and display. Of course, there's not going to be any pressure because there's no air movement. And we'll click close and then select the right contour. Make sure everything's right, click OK. So now if we check, we should have pressure and velocity in our thing. And then we're going to go run our calculation. Time step size is the length of the time step you want. So the smaller it is, 0.05, is going to give you very fine time steps. 0.5, half second, that's what I'm going to do. I just don't feel like dealing with it. The number of time steps is just how many time steps you actually want in your scenario. So in this case, time step size 0.5, number of time steps 100, 500 seconds. I'm going to go ahead and click calculate. And so what it's going to do, it's going to open up my scaled residuals, which is telling me where it's converging to a solution. And then in my contours, it's going to kind of show me each iteration as it goes and be like, all right, here's what's happening. And if your solution doesn't look like this at the bottom, you messed up. If it's broken down into smaller sections, you may have had one of your solution animations selected as iteration instead of time step, so you might need to go fix that. All right, so once your actual thing is converged to a solution, I'm just skipping through all the calculations right now. You can kind of see where it ended up. This is the last time step that we're going to see. So I'm going to show you how to create the animation. You'll go down to animations, select solution animation. Then we'll go ahead, unselect use store view, scroll in to however detailed you want. If you want to scroll in exactly on the car, that's where it's going to do this animation at. And what this is showing me is just kind of like how everything's looking. I can click play, and that's what it's going to look like whenever I save it. And so what I'm going to do now is I'm going to go ahead and change my write/record format to MPEG. That's just my preference. I think it works as a better file, and I'll click write. So it's going to kind of do its own thing. You can kind of see it changing and everything, but then a lot of the times your program will say not responding. That's okay. Just give it space. You can go eat a snack or whatever. Just let it do its thing, and then it'll all work out.